Alright, next Math C videos. We're going to factorize polynomials, and this time we're going to do it with complex numbers. So there's a little brief revision of a couple of things we need to make sure we know how to do as far as factorizing, standard factorizing. So let's just quickly look at the dots rule. Number one is the dots rule. This is the most important one. Here's the rule: a squared minus b squared equals a plus b bracket a minus b bracket. Okay, dots, difference of two squares. My two squares, because both of these have to be perfect squares, an a squared and a b squared. D for the difference, because it is a minus. It has to be a minus to factorize it like this. Although when we get to the complex ones, you'll see that we can actually do it with a plus. That's all because of that I squared equals minus 1 thing. Anyway, so have a look through these examples. Make sure you understand how to do those. Just of interest here, this 3x squared. If I want to write this whole thing as a perfect square, I have to square root 3. Alright? Put it in brackets with the x. Okay. The other one is complete the square. Okay, this is where here's an example. Okay, x squared minus 6x plus 4. That middle number, the coefficient of the x, I have to divide that number, the minus 6, I have to divide it in half, divide it by 2, and I get a minus 3. Okay, and I take that minus 3 and I square it, which is of course 9, and I have to add that and I have to subtract it. Okay, when I've added it, that's how I've completed the square. Okay, you can look through these notes, but what I've done is this x squared minus 6x is part of a perfect square, and the perfect square that it's part of is x minus 3 squared down here. Okay, x minus 3 squared, and the minus 3 because that's half of the minus 6. Okay, x minus 3 squared is what these first three add up. Is what these first three equal to. Okay, if you expand x minus 3 squared, you get that. This minus 5 here is the last two, plus 4 minus 9. From there, I use, once I've got to this point, I use the dots rule, and I rewrite this 5 as a square root of 5 squared, and then I can apply that a plus b, a minus b rule to get this for my final factorization. So complete the square is the king of all the factorizing. That you can do it with any factorizing thing. Okay. So there was just another example to look at. Okay, so make sure you understand all that, because otherwise you're going to have a lot of difficulty when we factorize complex numbers. Okay, first example, factorize z squared plus 9. So z is the standard letter we use instead of x in complex numbers. So if we want to use the dots rule, so we want to write this as z squared minus something squared. Okay, so this something squared, this whole part here has to be equal to, in order for this to be the same as z squared plus 9, this box must equal a negative 9, right? Because z squared minus a negative 9 is z squared plus 9. So basically what goes in the brackets is the square root of negative 9. And what's the square root of negative 9? It's 3i, plus or minus. We'll just go with the plus. Alright, so now I can factorize this. It's a dots rule. It's just equal to z plus 3i, z minus 3i. And that's it. Done. Next. Okay, factorize z. Let's do z4 minus 16 over c. Alright, so now we've got a fourth power. Can we use the dots rule here? Let's try. Can we use the dots rule? Can we write z to the fourth as something squared? We can write it as z squared squared. Okay? That is the same as z to the fourth. And of course, 16 is 4 squared. So, it's a minus, so we don't have to worry about changing to an I or anything. So we get z squared plus 4, z squared minus 4. Okay, but we want to factorize so that we're down to just z, okay, not z squared. So, this one is the same as the previous factorization, z squared plus 9, it's similar to that. I can rewrite this as z squared minus 2i squared. And this next part, of course, this is just a basic dots rule of z plus 2, z minus 2. Alright, so I get factorize this now, z plus 2i, z minus 2i, z plus 2, z minus 2. Okay, it factorizes down into 4. So this was a polynomial, the highest degree is a 4, and I get 4 factors. This, the highest degree was a 2, and I got 2 factors. This is going to keep happening. Okay, next example. Factorize z squared plus 4z plus 13. Okay, this one, so going back to that, complete the square rule, so we get z squared plus 4z. I'll move this 13 over here, so we have to take half of this 4, which is 2, square it, which is 4, and add that here. And then we minus it over here. So this becomes z, half of that 4 was 2, that's a positive 2, we put that for this part here, and the second part I've got plus 13 minus 4, so that's plus 9. Alright, so now dots rule. I want to make this, so this is basically a minus of a minus 9. I'll do it this way, just showing you that extra step. Plus 2. So minus the square root of minus 9, which is 3i squared. So we get basic dots rule, z plus 2 plus 3i, z plus 2 minus 3i. Just make sure you don't change this plus to a minus. It's only the one before the 3i. Okay, that's done with z squared, so we've only got 2 factors. Okay, so let's do another example next. Let's factorize 6z4 plus z squared minus 1. Alright, this is going to be, we could do it a couple of ways. We could look at, let's make a substitution, w equals z squared. We could do this, okay? And rewrite this. Since they're both even powers, this is the same as factorizing this, okay? Which, so now we're going to get two brackets, 6w, it's probably going to be 3w and 2w. It's probably going to be 1 and 1 here to get this minus 1. We just have to figure out one of them should be a minus and one of them should be a plus. And I believe this will work because this will give us for the middle term. So we're okay for the first and last term. We've got 3w times 2w is 6w squared. Plus 1 times minus 1 is a minus 1. Now we've got a middle term of 3w times negative 1, so that's negative 3w, and we add to that 1 times 2w. So that gives us negative 3w plus 2w is negative w. So this is the correct factorization. So now we can just swap back our z squared for this w. And you could have just done this all in one without using the substitution, whatever works easiest for you. Alright, so we're going to use dots rule on these, on both of these two factors now. So this one, this is the square root of 3z squared. I'll just use square brackets to make this easier to read. Plus 1 is the same as minus I squared. Okay, I've got to have a minus to use the dots rule. Next one, square root of 2z squared, and this is just a minus 1 squared. Okay, so now I can factorize both of these. Square root 3z plus I, square root 3z minus I, and then the next square brackets, square root 2z plus 1, square root 2z take 1. Okay, finished. So those are the easier factorization ones. The next video we get on to the little bit harder ones.